All right, the last section in this unit, you guys, section 3.7, talks about creating valid arguments, okay? So make sure you're on this second to last page in your notes packet, 3.71, and please write this down. So an argument consists of two parts, the given statements, okay? So something has to happen. We call these the premises, and the conclusion, okay? So we've actually been working with this quite a lot, creating truth tables for all of this. Now we're just giving it an official, name for all this. So a valid argument is true, it's valid, when the conclusion is true when the premises are true. Because if the premises are not true when they didn't happen, when they didn't take place, the whole argument is invalid. So that's why an invalid argument, it's also called a fallacy, something that's not valid. So the idea is that we're going to be creating a truth table and checking if everything is true, it's going to be a valid argument. And if we get some false, it's an invalid, okay? But this happens when the premises are true, and that means when they actually happened, when they're true. There we go. Okay? So, Jacob and Ricky, do that later, okay? Let's focus on this, whatever you guys are working on. Oh, never mind. I thought you guys were doing something. So here's an example, and this is what you guys will have to do to create an argument. Before I explain this, write this down. If you see something that looks like this, 3 dots, this stands for therefore. Just like we have symbols for and, or, this 3 dots, they mean therefore. Let me show you what that looks like. In the practice packet, you're going to see something like this, where you'll have this right here, you have something else, and there's going to be a line, and you have these 3 dots, and that is read therefore. So that's like a conclusion that follows. If something happens, then something else follows. But in logic, we use these 3 dots to mean therefore. If you get premise 1, if you get at least 95% average on homework, then you get a 3% bonus. Done. Premise 1. So if something, then something else follows. Kind of like my example with, if you all get A's on the test, then I give you donuts. Premise 2. So that's given to you because you need to know, hey, what happened? Did you end up doing the homework? Yes, you got at least 95% average on homework. In my example, you all get A's on the test. So those 2 things will always be given to you. Now, what's the conclusion based on this? For my example, if you all get A's, you get donuts. And actually, we could do that. If you all get A's, I will bring you donuts. That's going to be a happy day. What about in this example in the notes? You get a 2% bonus. So, you guys are looking at me kind of like, what does she want? That's it. Like, there's a conditional. If P, then Q. P happened, so what's going to happen? Q is going to happen. So write all of the statements in symbolic form. Premise 1. It's an if and then statement, so it's going to be P arrow Q. If P, then Q. P is this. Q is this. Premise 2. What happened for premise 2? P happened. You got 95% on homework. And the conclusion was you got the bonus, so it's just Q. So what you're going to have to do when you get to section 3.7 in the practice packet, they will give you something like this. You will have to rewrite it with P, Q, and R sometimes. And then to check if it's a valid argument, we create a truth table and we check if it's all true. Now, how do you create an argument? This is the formula that I want you to write down. And this is something you can add to your gold sheet. This is something that you'll have to kind of memorize. It's premise 1, so this, and premise 2, and then when it's like this, therefore, it turns into the if and then, okay? If all of this happens, then the conclusion takes place. If I make you a promise, you get 95% on homework, I'll give you the bonus. You actually got the 95% on homework. I am going to hold up my promise and I will give you the 2% bonus. So here's how you would write it. What's premise 1? We have it right here. It's P arrow Q, put it in parentheses. So that's just this. Then I'm going to use the and, because that's what this is like what you have to memorize. That's part of the formula. And what's premise 2? P. So that's this one right here. And since this is the first part of the argument, we put brackets around it. So whatever was the first thing is right here. So because this might change. You might get different things right here. Right? So this goes first, and P happens. And then we do the arrow. And then it's the conclusion, which is Q. So this might look different in here, right? Because depending on what the argument is, you'll see that. But what's important is that you have the and then the arrow, and then this is whole thing in parentheses. Sometimes you need the brackets, sometimes you don't, depending on how big your letters are. So now let's do a truth table for this. Start with P and Q like always. And then we build the truth table. So the first thing that we're going to do is the if P then Q. Then I'm going to do the brackets, which is if P then Q and P. And then the whole thing, so you have to rewrite the whole thing. And then, you guys ready? Let's fill this in. So, if P then Q, if true then true is true. If true and false, if true then false, false. If false then true is true. If false then false, that's also true. Remember, if then, check your gold sheet, false, false for an if then gives you true. Now we're doing the end statement with what I just found and P. So, true and true is true. True and false is false. False and true, false. False and true is false. Finally, the last thing is to do an if and then statement again. And what we just found right here, and Q. So it's this one. If true, then true. Whenever I do these, you guys, no matter how many I've done, I always say this in my head. If true, then true, true. If false, then false, it's still true. If false, then true, because you're going from this to this. True. And if false, then false, it's true. So by creating this, we found that all of these are true since the conditional above is true for all truth assignments. It's a tautology. Do you remember tautology? Self-contradiction and then the neither. So what that means that this is a valid argument. And we are done. So when you see section 3.7 in the practice packet, which we'll get to at some point, and actually, it's actually also in 3.6. This is really 3.7. Use the truth table to determine whether the symbolic form of this argument is valid or invalid. What you're doing is creating a truth table for all of this and then seeing if all of them come out to be true. So, In your packet, technically we're done with everything. Actually, I'm going to ask you to write down one more thing. Take your packet and go back to this blank page in your notes. There's nothing there. We're going to memorize some, write down what you have to memorize from what I just talked about. Okay? So here's what you have to memorize. The first one is, how do you negate an or statement? So this is, we're just writing this in your notes packet where you have all this space right before where we took notes. How do we negate an or statement? What does it change into? An and what do we have to do with P and Q? Negate both. So it's going to be not P and not Q. So this is the De Morgan's law that I was talking about, and basically it means, how do you negate an or statement? How do you negate an and statement? You negate both, so it's not P, but now what does it switch? The and switches to or. And the last one, how do you negate a conditional? How do you negate if P then Q? We just did it in the beginning. You guys did book problems on this. So first keep P, and then what do we change that to? And we negate Q. So I would encourage you guys to perhaps take a picture of this, keep it on your phone over the weekend. Make sure you look at this, because if you have this memorized, you're going to, be better off creating these. Okay?